Example 6. In this example, we're going to be determining the area of the region between the curve y equals 4 minus x squared between 0 and 3 and the x-axis. So the first thing you need to do in this problem is graph this on your calculator. When you graph this, make sure you're only looking at the interval between 0 and 3. So when you graph it, you'll notice what's different about this problem is that the area underneath the curve and between the x-axis is not always above the x-axis. So you'll notice right here at x equals 2 that the area goes from being above the x-axis to below the x-axis. So when we solve this problem, we're going to take that into consideration. And what we're actually looking for is this area, and we'll call it area A. And then we're going to add it to this area, which we'll call area B. If we take the integral from 0 to 3, we will actually get the area A minus the area B, because an integral takes into account the negative and subtracts it off. So in order to get the total area, we're going to partition 0 to 3 into two subintervals. We're going to separate those intervals into where the graph crosses the x-axis. So the first subinterval will be from 0 to 2, and the second will be from 2 to 3. 0 to 2 is going to represent region A, and 2 to 3 is going to represent region B. So to evaluate that by hand, we get that the integral from 0 to 2 of 4 minus x squared dx is equal to, well, the antiderivative of 4 minus x squared is 4x minus x cubed over 3 from 0 to 2. We get 16/3. So 16/3 represents the area of the blue shaded region. Now we have to find the integral from 2 to 3 of 4 minus x squared dx. Notice that it's the same function we're taking the integral of. So the antiderivative is 4x minus x cubed over 3 from 2 to 3. And when we evaluate it, and we get negative 7/3. So notice that the total area is the sum of the absolute value of each integral. So what you do to find the total area is we take the absolute value of the first area, which was positive anyways, plus the absolute value of the second area, and you add those together. So when you do that, you get 23/3, and that would be the total area of that integral. How to find area analytically. So these are some steps that might help you determine the area under a curve analytically if you don't want to draw the graph every time. So the first step is to partition A to B using the zeros of f. That's when we partitioned it from 0 to 3 into 0 to 2 and 2 to 3. Then we integrate over each subinterval to find the area, and then we add the absolute value of the integrals. That's how we determine the total area of the integral. So what I want you to try is to determine the total area between y equals cosine of x and the x-axis on the interval 0 to 3 pi over 2. So use these three steps and try to determine this on your own. All right, let's see what we got. So we have f of x is equal to cosine of x. So what we need to do is we have to find the zeros. So we set the function equal to 0. So 0 is equal to cosine of x. So x is equal to pi over 2 and 3 pi over 2. these are the x values that will make cosine of x equal 0. So what we're going to do is we're going to partition 0 to 3 pi over 2 into two intervals, which is going to be 0 to pi over 2 and pi over 2 to 3 pi over 2. Alright, so we take the integrals, and we get the integral from 0 to pi over 2 of cosine of x dx is equal to sine of x, because sine of x is the antiderivative of cosine, from 0 to pi over 2. So we get sine of pi over 2 minus sine of 0, which is going to be 1 minus 0, which is 1. And now we need to evaluate the integral from pi over 2 to 3 pi over 2 of cosine x dx, and we get sine of x from pi over 2 to 3 pi over 2, and that will give us sine of 3 pi over 2 minus sine of pi over 2, which is going to be negative 1 minus 1, which is negative 2. So now to find the total area, you're going to add the absolute value of each area up. So you get 1 plus 2, which is 3.